right, let's talk about how to solve quadratic equations. So the typical form for a quadratic is this right here, which is a situation where a, b, and c stand for constants and the x's stand for variables. Now quadratics typically have an x squared term and then a single x term and one term that doesn't have an x involved in it. So if we look at this second situation, how do we get from this to something that looks like this? Well, the typical method is known as FOIL, and that means multiplying the first, outer, inner, and last numbers. So the first numbers would be the x's, which gives us x squared. The outers would be x times -2, which gives us -2x. The inners would be +5 and x, which gives us plus 5x. And then the last would be +5 minus 2, which gives us -10. Now if we combine these middle terms, because they both have x in them, -2x plus 5x equals +3x, so we end up with x squared plus 3x minus 10, and this was all set equal to 0 initially, so we know this equals 0. And this is the final form that we typically have when we look at a quadratic. And it came from this through the FOIL method. So how do we get back to the FOIL method by looking at this equation? Well, I know that this situation here is going to represent the two constants that were multiplied together. So I have a positive and negative number because when I multiply two numbers and get a negative, one is positive and the other must be negative. And they must be like 1 and 10 or 2 and 5. And these are the common whole numbers that multiply to give 10. So I do a quick factoring of -10 to figure out what numbers multiplied together would give me 10. Here's my situation. Now if one's positive and one's negative and they add to +3, that means the difference between them must be 3. And that must be 5 and 2. And it means that also the larger of them was the positive number because we ended up with a positive number. So it was +5 and -2. If it was -5 and +2, we would have gotten -3 out, but that didn't happen. So we're focused on +3x, which tells us a +3 difference. And that means we had +5 and -2. Now, what this tells us is the opposites of the roots. So the roots are the solutions to the formula. They're what I'd plug in to solve for 0 here. And if I make x equal +2, that would zero out this whole part, which would zero out anything on this side and produce a product of 0 total. So +2 is one of the roots, and then -5 is the other root. So the opposites of these whole numbers, these constants here, are going to be your roots. So the roots to this formula, or the solutions, are +2 and -5. Okay, now looking at this second formula, we have a positive number here and we have a positive number here. And what that means is we had a situation with all positive numbers. So we had x plus something times x plus something, which means both the roots will be negative since the roots are the opposite of these constants. Now what numbers multiply to give 12? 1 times 12, 2 times 6, 3 times 4. And which of them, if I added them together, would give me a 7? Well, that's 3 and 4, which means we have x plus 3 and x plus 4, and the roots are -3 and -4. So there's our roots. That's how we solve it. I always start by thinking about the factors of 12 or the factors of this last number here. If I'm shown something that looks like this sort of format, the standard quadratic format, make sure it's always set equal to 0 before you start solving. If it was equal to something like -3, I would add 3 to both sides to knock that out, and I would get +15 here instead, and then I would have to solve that accordingly.